Hello everyone, my name is Anderson Oliveira. I'm a PhD student at PUC-Rio, Brazil, and today I present you on our recent study entitled, When Are Smells Indicators of Architectural Refactoring Opportunities? A study of 50 software projects. Well, the software architecture is defined on the early phases of a software. It often corresponds to a set of high-level design decisions that define how the system is modularized and how its components communicate with each other. These decisions can be taken during the development of the system and also during its evolution. When these decisions have a negative impact on quality attributes of the system, especially on structural quality of the system, we have an architectural problem. One example of an architectural problem is the concern overload that happens when a component fulfills too many responsibilities. The architectural problems are so harmful in the system that they are one of the main reasons for contribution rejection on open source projects. Also, it can lead the software to high maintenance costs. In a worst case scenario, it can even lead the software to its discontinuation. So developers need to identify and remove them. The most common way to do that is through refactoring, which consists of program transformations used to improve the structural quality of the system. To remove an architectural problem, the refactoring must affect the system architecture. In this case, we have an architectural refactoring. However, developers can face some challenges when adopting the architectural refactoring. There's a couple of reasons for that. First, we have the missing architectural documentation. In this case, the developer don't have the documentation of the architecture, and they have a problem on identifying where are the architectural problems of the system. So they end up thinking that the refactoring task is costly and risky, especially because they don't have a guidance on how to locate the architectural problems to remove. So they end up with a lack of knowledge on how and when to perform the architectural refactorings. So developers can use the artifacts that they have, in this case, the source code. So in this case, developers can use the code smell. The code smell is a structure in the source code that usually corresponds to deeper problems in the system. In this case, architectural problem. In fact, some studies have even shown that the presence of multiple smells can indicate architectural problems in the system. To exemplify how the developers can use the smells to indicate the refactorings to remove the architectural problem, let's consider this figure, where we have the enrollment service class. Here, as we can see, this class is implementing two concerns, the query concern and the management concern. So here we have in this class the concern overload architectural problem. This is happening because the other concern, in this case the query, is being implemented in the wrong component. When we analyze in more details this class, we see that it has some code smells. For instance, we have a method that has feature envy. A feature envy happens when the method is more interested in other class rather than the class where it's being implemented. In this case, the feature envy here can indicate that part of this functionality in this method is trying to leave this class, maybe trying to go to the right component. This end up increasing the coupling of this class. So this class end up with the code smell intensive coupling. And finally, since some methods can be implementing more than one concern, they can be long methods. This is a case where the developers could use these code smells as hints for refactorings to remove the architectural problem. Here they could use some move methods and remove these code smells and the architectural problems. However, there are cases in which a set of smells may not be enough to indicate architectural problems. So because of that, in this study, we decided to investigate whether code smells can indicate refactorings to remove the architectural problems. For that, we focus on analyzing elements that were affected by root-canal refactorings. This type of refactoring are the ones that are targeted at improving the system internal quality. So the elements that are affected by this refactoring probably will have an architectural problem. Also, we categorize the refactor elements according to the number of smells. So we could analyze if there was any relation between the code smells and the refactoring. We divided the elements into three groups. The smell-free group, where we have the elements that don't have any smell. We have the single smell group, where we have the elements with just one smell. And we have the multiple smell group, where we have the elements with multiple smells. So we followed some steps to perform this study. First, we did the project selection to select the projects based on some criteria that allowed us to select 50 software projects. Then we did the code refactoring detection using the refactoring miner tool that allowed us to collect over 50,000 refactorings. Then in the third step, we performed a manual validation on the refactorings identified by the refactoring miner, so we could see if the precision was right for the high precision of high precision of refactoring mining was still high for our set of systems, and we classified almost 5,000 refactoring for that purpose. And finally, we did the code smell detection using the organic tool, which is a tool that are based on some rules. That tool allowed us to collect 17 different types of code smells of different granularities. Once we collect and analyze the data, we had our first results. So here we have the distribution of refactored elements. And the first thing that we can see here is that in most cases, more than 80%, the elements refactored were affected by at least one smell. So this can indicate that indeed the code smell can be used as an indicator for refactorings to remove architectural problems. But here in this pie chart, we also can see that in most cases, the elements were affected by multiple smells. So that shows us that when the developer is focusing on repairing deteriorated code, most of the refactorings they apply on elements that have multiple smells. So the developers can use this set of smells to identify the refactorings to remove the architectural problems. We also decided to analyze the relation of the code smells, the architectural problems, and the refactoring, so we could better understand how they relate, how the code smells can indicate the refactorings to the architectural problems. And that provides us with some interesting results. For instance, we identified that complex class and God class usually they indicate architectural refactoring when they occur together with other smells. This makes sense since the God class is more related to a class that has many responsibilities, accumulates many responsibilities. And the complex class is more related to a class that is big in size, large in size, and has a high complexity. So one of the main reasons for the co-occurrence of these two code smells may be that a class is dealing with too many responsibilities and is too complex. And this type of class may indicate some architectural problems, such as the concern overload that I presented before, and a scattered concern. However, we identified that when these code smells present in the source code alone, they usually are not sufficient to indicate an architectural problem. And this is aligned with the empirical knowledge that we have. but we went further and decided to analyze the code smells isolated that are related, that appear together when with the complex class and God class, for instance. And since, as we saw before, that in most cases the refactored elements are on elements with multiple smells, we decided to evaluate that, analyze that, and we derived a smell pattern. A smell pattern represents one or more types of smells that are likely to indicate an architectural problem. For instance, let's consider one of our patterns, which is the multiple smell pattern. In this case, we have a pattern to remove concern overload. Here, we have 7 code smells, complex class, divergent change, feature envy, God class, and so on. And they can be hints for the developer to identify the right refactorings to remove the concern overload. Let's go back to our first example. And here, we will see that it has 4 code smells of 3 different types. And these 3 different types are presented in the multiple smell pattern. And here, the developer just needed these 3 types of smells to identify the concern overload. That means that the developer don't need to identify the 7 types of code smells on the class to identify the architectural problem. It can be some combination, such as that, of feature envy, intensive coupling, and log method. However, if a class has all the 7 code smells, it could mean that this class have a higher degradation level. So to confirm that this pattern was indeed enough to remove the concern overload, we did a manual validation on some classes that could have this architectural problem. And we identified that in 64% of the classes with multiple smells, they had the concern overload. So indeed, this pattern can be used by the developers as hints to identify the right refactorings to remove this concern overload architectural problem. This is just one example of a pattern that we created, but you can find many more in our paper, and we invite you to read the paper and analyze these other patterns. So to conclude, these are our contributions. We did an analysis of 50,000 refactored elements from 50 open source projects. This is important, so if anyone wants to replicate this study, it would be easy. And we provided a catalog with patterns of smells that indicate refactoring opportunities for the developers. So they can use these patterns to identify the refactorings needed to remove the architectural problems. Tufano et al. Found that smells are introduced in the system as a consequence of maintenance and evolution activities. But we went further and explained when these smells are related to architectural problems and refactoring. So how the smell can guide the developer to identify the refactorings and to remove the problems. And finally, Souza et al. Showed that developers rely on smells to identify the architectural problems. However, they did not investigate when the smells can be used to indicate the refactorings that are needed to remove these architectural problems. And we also identified that there are some cases in which the code smells cannot indicate an architectural refactoring. As I presented before, there are some cases in which a God class and a complex class alone is not sufficient to help the developer on identifying the refactorings to remove an architectural problem. So here we show how important it is to consider multiple smells and the right smells to identify the refactorings opportunities to remove architectural problems. Thank you.